Thank you for inviting me, and yes, thank you to Alex for this reference. It's a pleasure to be here, and ciao to everybody in Singapore. I have been there several times. That's why I'm so happy to do this online event in the hope that the world opens up and then I can come there and do it live once. Fingers crossed it's gonna happen soon. So let's talk about connaissance. This is a talk which I prepared for an Agile conference in Spain a couple of years ago, and I was a little bit puzzled in that conference because it was perhaps the biggest Agile conference in Spain, where thousands of people participated, like 20 tracks in the conference, but there was just one technical track. Every other tracks were about organizations and methodologies and other things, and only one technical track. So there will be some point about that in between these talk. The talk is about connaissance, which is going beyond coupling and cohesion. Coupling and cohesion are concepts that are quite popular, at least for those following software craftsmanship and the best practices. But the concept of connaissance is somewhat emerging recently. And to me, it is a wider classification over coupling and cohesion. We will see that connaissance is everywhere in our code. It is the means to achieve programming in itself. It is the kind of connaissance that make the difference. That's why I choose this quote from Van Gogh about connaissance. They say great things are done by a series of small things brought together, right? And those small things are the small element of connaissance, which if we organize it well, will make a great things. Otherwise, it will make a great ball of mud, right? So who am I? I am the co-author of Agile Technical Practices Distilled, a learning journey in technical practice and principles of software design. I wrote this book with Pedro Santos and Alessandro Di Gioia. You can see them in the picture. And it was a great success for us. We won several awards as Best New TDD book, Best New Continuous Integration book, Best New Agile Software Development book. So well beyond what we could ever imagine. And we have so many great feedbacks. It made really worth the effort to write this book. But I am recently also an entrepreneur. I just co-founded Alcor Academy, where we help CTOs to promote a culture of excellence through our innovative technical training. What we do a live mob programming training over Zoom, and we actually have a good success, and we are able to get all the people so enthusiastic about writing good software that actually change the culture of the environments that do our training for enough time. In effect, this talk is one of the lessons of our training program. It's actually the first lesson of the flying module of our course. Of course, our training program is not just listening to me doing presentations. Otherwise, it would be really boring, right? After some theory, we always have some practice. And after the theory, we have exercises, katas, and other kind of exercises that are meant to understand in practice the theory we just explained. And we do it in mob programming with me and Alessandro Di Gioia, there with the people and programming together. Of course, we stay on the back, we do the facilitator in the mob. We don't do always navigation or driving, but we come when it's time to explain the concepts. So let's begin this lesson. Right? I learned a lot. I learned a lot about connascence listening to the talks of Jim Weirich. Jim Weirich was a great Ruby programmer. He was very famous in the Ruby world. For any one of you that use Ruby, if you use rake build, you use a tool that was done by Jim Weirich as an open source. So I suggest you, if you want to understand more, to look at this talk because they is perhaps better than me to explain many things. He actually titled one of these his talk, "The Grand Unified Theory of Software Development," which for him was connascence. Perhaps a little bit too big as a title, but still a very interesting subject. I like to mention Jimmy Weirich because he left us on 2012 when I started to listening to his talk online on YouTube. I was blown away. I had so many questions for him. I wanted to reach out and ask him things. Unfortunately, I realized that he died just a few years before that, so I couldn't do it. This is the page that, the tribute page that GitHub left on his account. So thank you, Jim. So connascence, what does connascence mean? Right? Connascence derives from Latin. It's co plus nascens. Nascens means arising young, right? And the present participle is to be born. And co means together. So what connascence means is the birth and growth of two or more things at the same time. So two or more elements in our code, they can be fields, method, classes, parameters, variables, but also tasks, people, whatever. They are connascent if a change in one element will require also a change in the others. Oh, and here, apparently, is very similar to the concept of coupling. But as we will see, the concept of connascence is wider and it can span outside our code base as well. It's a taxonomy in 3 dimensions. That's where it's superior to coupling and cohesion because it gives us a better way to analyze what we are doing. There is a degree. The degree says the size of the impact of these connascence, right? Because it can be 2 or more elements. The more the number of elements impacted, the bigger the degree. And it has a locality because two things can be close together, so the locality is small, but they can be very far away in our architecture. So there will be very big locality. And then strength. Strength is very important, and it is related to the kind of connascence, because we can have connascence of very different kinds, and not the same kinds have the same strength. So we have a taxonomy in 3 dimensions, which give us a clear idea of the direction of our refactoring. If the degree is high, we want to reduce it. If the locality is apart, we want to make it close. And if the strength is very strong, we want to try to transform that kind of connascence in a connascence of a weaker type. I know what you are thinking. Show me the code, right? This is too abstract. So yes, I agree. Let's see an example. So this is a class. Apparently, everything is fine with this class, right? We have a constructor which take 3 values, and then we have a display that shows us the that's apparently is really good. And here we have several kinds of connaissance. For example, let's look at this. How this variable appears in 3 places inside our code. Right? And if we change the name somewhere in our code, we need to change it everywhere in order for the program to work, because these 3 elements are connaissant. But it happens also here, right? All these 3 variables has the same name. If we change one, we need to change the other. But also inside our method, we have more connaissance, right? If we change the name of those parameters, we need to change it also in the line of the methods. And now here you can see that everything in our code is like that. We have everything appearing 2 or more times to make it work. It's because we need to fly, to move the information from a place to another. So there's always 2 or more places. And this is a good kind of connaissance. This is what we should use all the time. This is connaissance of name. And now we have another kind of connaissance in this piece of code, right? For example, if I change the type of this variable, I need to change it also inside the parameter. Otherwise, not gonna work anymore. Same for this one, and same for this one. These elements are connaissant, right? This is connaissance of type. And this is another really good kind of connaissance, right? Let's see how they score in our ladder, right? This is connaissance of name and connaissance of type. Very good kind of connaissance. We should just use this, ideally. And you may think that's the case, but it's not always like this. So those are static kind of connaissance, right? They are a kind of connaissance that are discoverable at compile time. If we change the type in the example of before, it's the compiler say, hey, you broke connaissance of type. That's what type languages do. They guarantee the correctness of connaissance of type by the compiler, right? So what happens in languages like JavaScript? Well, the problem with language of like JavaScript or not strongly typed language is that connaissance of type is not discoverable at compile time anymore. It becomes a dynamic piece of connaissance, and that's why makes everything more difficult. But let's see another kind of connaissance, which is a little bit less intuitive, right? And let's see this class called notificator, right? This class sends email, right? And when we create an email, we need to have a recipient, we need to have a sender, and we need to have a body, and then we need to send the email, right? So when we send the email, we actually have to do a code like that and write 3 strings in the send email message, right? We have a recipient, a sender, and the method. The problem with this piece of code is that they are all three strings. And when we want to use this method, we actually just see that we expect to put three strings. But if we change the order of those strings, the method might be wrong, right? Because the first parameter is the recipient. The second parameter is the sender. And the third parameter is the message. So we bind the position of these parameters in our method call with their meaning. And this is called connascence of position, because it's the position that gives the meaning of that code, right? And this is somewhat acceptable if we have little number of parameters. So if the degree is small, it might be acceptable because it's still not too complicated. So connascence of position happen when multiple components must be adjacent or must appear in a particular order, often passed with a positional structure. Sometimes you don't pass it just in the parameters. Sometimes you build an array and constructed with the parameters. I've seen many times in legacy code, right? Or a tuple with a lot of parameters. And then you need to understand how the first one means this, the second means that, you know, how many times. That becomes very, very difficult to understand very quickly. That's because there is a high degree of connascence of position. So how strong is it? Well, it's quite strong. It's the strongest one of static kind of connascence. How can we fix it, right? Because identify it is good, but we want to fix it, right? So to fix it is quite simple. We can, for example, create a class that represents a recipient, and one that represents a sender, and one that represents a message. And this, if we do it like this, we don't have strings anymore. Everyone has its own type, and the type represents exactly what it is. And we solve it, rolling back to connascence of name and type, right? Another even better way to solve it would be, for example, to create a notification type and maybe having a fluid interface to set up address to, from, and with message. Also here, it doesn't change that we transform connascence of position with connascence of name and type. Let's see a different, let's see what happens if we have a big degree of connascence of position, right? With a tuple, right? Let's consider this order processor where we have a tuple, right? In the first, process order with item 1, and if order if item 2, send the invoice, right? It's not very clear, but somewhat if the degree is 2, it's still understandable, right? It's a step in our mind, but we can reach it. What happens if we have connascence of position of degree 6, right? Item 1, item 2, item 3, and I'm like, what is that, right? This is the grade 2, this is the grade 5, right? Very, very hard to understand, right? So when we call it, you see, new tuple order true, it's okay. With the grade 5, we have order true 1, 2, 3, 4, 5, daytime now, jack false is like, what the hell is going to be that stuff, right? Too much. So it's like, wow, what's that? So the degree of connascence of position is very, very important. So more than 2, it's absolutely to clean up, in my opinion. But let's say a different kind of connaissance, right? So also here we have seen connaissance of name and type, but we have also some worse kind of connaissance here, right? So what happened in this class? If we instantiate it with a time like this, right? 27th hour, minute 76, and second 82, right? This is not a valid time, right? So if a class is done like this, here we instantiate it wrong and it's still working, right? We have an invalid state which is not checked. When you have an invalid state and it is not checked, that is called connaissance of value. Connaissance of value happen when two or more components values are related or have an intrinsic range of validity in their input, not expressed by their primitive types. So here in our example, let's go back. This new time 27, 76, 82, it's represented by integer, which can be any time. And so here we will have a range of validity, which is actually not checked. That's the problem with this code. How strong is connaissance of value? Connaissance of value is really, really strong. So it's one of the worst kind of connaissance. It is quite often, we can see it quite often. So how do we fix it? Well, as a bare minimum, we can validate, right? A class should participate in the information flow if and only if its state is valid. So if somebody tries to instantiate a class with an invalid state, it needs to throw straight away. It shouldn't be possible to instantiate a class invalid. So bare minimum, we can validate, right? Another way to solve this problem is to create a type system with some primitives that are specific for the validity of that object. Hence, if we create tree enumeration like this, it's going to be impossible to instantiate this class invalid. And so we don't need to validate anymore. This is a concept that is fundamental for great software design, to create an extension of the type system to have the type system of your domain. And that's very, very useful, because in this way, you will have the compiler to check all the validity of all your objects. And that's the power of typed languages. So here, with this simple tree enumeration, we made invalid state unrepresentable, using always connaissance of name and type. See, another type of connaissance, there's a few, right? Let's think about a web page with a checkbox where people can check which transport they use to go in the office. Obviously, I did this talk before the pandemic, right? Because now it is not a very actual example, right? So if we do like that, then there will be a controller that says, okay, so based on the string that comes from the form, we can do something different. And 1 means bike, 2 means car, 3 means train, and 4 means bus, right? How many times did we see it? Well, this is what we have done here is we create a convention where one means bike, two means car, and so on, just because it's the way we have done it, right? So when we do something like this, we introduce connascence of meaning or convention. And connascence of meaning happen when two or more components must agree of the meaning of a specific value, right? Like the two before, one is bike, right? Because we decided like that. So when we introduce a convention which is not expressed by our type system, we have connascence of meaning. How do we solve it? Well, how hard is it? First of all, well, it's not really hard. It's just after types might be acceptable. The thing about connascence of meaning is that it's very, very easy to clean, right? It's just enough to introduce a constant somewhere in our code, and now there's no convention anymore. Now bike means bike, car means car, and train means train, right? It's much more expressive. There's no hidden knowledge. And so we have cleaned it still using connascence of name and type. Next one is a very interesting kind of connascence, right? So let's suppose we have a checksum algorithm, right? So it's a checksum that in this case sums the numbers and then add the last number in modulo 10, right? To make the sum divisible by 10, right? So the first case is true and the second case is false, right? Very simple. This is very, very popular to check if a file has been tampered, right? How do you check if it is tampered? Well, you agree the algorithm you use, and then take the file, apply the algorithm on the file. If the end result is the same, it means that it cannot have been tampered, right? But in our code, that is not as useful, right? So if we see this implementation of those two methods, we have a repetition of the algorithm in two different methods, right? When we do something like this, we have a divergent code smell, right? Because if we want to change the algorithm, if we want to make it, oh, well, let's make it divided by 100 now because it works better, we need to go in both places and change it. Otherwise, it's not going to work anymore. So this is connascence of algorithm. We have connascence of algorithm when two or more components must agree on using a particular algorithm. And this is the last of the static kind of connascence. It's quite bad. And also this one, it is very easy to clean, right? We just encapsulate the algorithm in a method or in a class if the component is too big. And also here, we use connascence of name and type to fix it. And now we go to the dynamic kind of connascence, and those are a little bit more difficult both to understand and also to find and clean. Let's see what happens when we have these components that send receipts, right? So basically, we have a receipt that needs to be sent to the customer, and then it needs to be archived, right? What's the problem here? The problem is that if I archive it before I send it to the customer, we will have an error. And this is called Connascence of Execution Order. Connascence of Execution Order happens when the caller of a component must have some unexpressed knowledge about the correct order of the methods to be called, right? For example, if you design an interface with 3 methods and you know that one method needs to be called before the other 2, otherwise the class breaks, that's connascence of execution order. And this is quite bad, right? For example, let's see a builder. A builder, the builder pattern, is an example of connascence of execution order expressed by convention, right? It's popular and quite straightforward, so it's not very, very bad, but it's still an example of connascence of execution order. For example, we need to set up the builder before we build the car. A good programmer will not make it throw an exception if we do that, right? But still, there is knowledge about how to use the order of the method, which is not expressed anywhere. If somebody open a builder, I've never seen a builder pattern before, it doesn't know that some method needs to be called before some others, right? So can we fix it, right? Because what if we want to remove it? Is it possible? Yes, it is always possible. Let's segregate the interface, right? Let's follow me here. So if instead of having a monolithic interface, we break the interface down and we don't have just I build cars, we have a I build cars with brand, right? Which spit out an I build cars with engine, which spits out an I build cars with color, which then spits out the car, which actually is the one that spits out the concrete. We can use it like this, right? It's gonna inherit from all these segregated interface, and we'll have a static factory method, which return the builder, right? So we can new it up, and now we cannot do anything else but have the brand, specify the brand. Then we need to specify the engine, and then the color, and then it's gonna build it. And also here we remove connascence of execution order using connascence of name and type and solid principle and some other things, but still connascence of name and type. Let's see another nasty kind of connascence. This one is the reason why I started to be very interested about connascence, right? Because many times I've seen in teams code like this with try.slip, right? And I don't like it, right? It's you are not in control of the time. So coupling with the time, it has always felt bad. But you know, I had no real arguments, right? Instead, once you understand connascence, you see that something like that is connascence of timing, right? Connascence of timing happens when the success of 2 or more calls depend on the timing of when they occur, right? And this is particularly nasty because time is not something that we can control. And in fact, it's a quite strong kind of connascence. How can we fix it? Well, usually the way to fix it is rethinking about the big design of the way we test things. I've seen a lot of these in testing with a message queue, in a synchronous message testing, where we send a message somewhere, and so we need to wait an amount of time before we receive it in the other side. But testing things like that means that we are coupling our test with the infrastructure. And if we couple our test with the infrastructure, we depend on an infrastructure in order to achieve the testability, which is something we don't always want to do. In this scenario, the way this is code that I took from a real life example. In this scenario, what I have done is, since of course you cannot re-architect a system many times, right? You go in a system, it is done like that. If you want to change the way they test it, you have to change everything, so it's not feasible. So the way I try to solve this problem was to avoid to wait the second every time we tested in the happy path. In the happy path, I could generate an event every time that the message handler receive an event, so that we could stop to wait just some arbitrary amount of time, but instead listen to that event, which was basically the proof that the message arrived, and that will speed up 95% of the time in those tests. Of course, the unhappy path, since the message did not arrive, we need still to wait for the timeout in order to prove the unhappy path. But it was just a few tests for the unhappy path. So overall, the speed of our tests improved a lot. Let's see the last type of connascence. This is a global counter, right? That is a singleton, anti or pattern. It depends. I don't want to go into that discussion. The last decades we can stay hours to discuss if the singleton was good or was bad. Who decided that it was an anti-pattern was because of this problem, that it is going to work only if the instance is correct, right? A global counter coupled to a specific instance is very, very bad, because it's very hard to ensure the instances, right? So this is called connascence of identity. And it happens when one or more components must reference exactly one particular instance of another entity to work. It's particularly bad. It's at the top of the connascence of the classic book, where this categorization has been defined in the first time. But we, in our book, introduce another kind of connascence, right? And this is a little story. The last kind of connascence, I found it once I was working in a team, and we needed to create a couple of new events for this event system in order to get something to work. And so I create this new event, I create all the infrastructure in my machine, and it worked perfectly in my machine. And at a certain point, we push to the continuous integration environment. And yeah, there's no reason why it shouldn't work, apparently. But when we push in the continuous integration environment, it broke, right? And so we were, I was puzzled, why is it broke? And no one in the team seemed to understand why it was broken. It should have worked, right? And then the most seasoned guy of the team, a certain point, was, oh, now I remember. Every time we add a new type, we have to change the build script in order to let it know that we have a new type. And I was like, you are crazy. Why do you want to do that, right? So every time we have a new event, we need to change the build script. You are always tweaking with the build script, right? And that's an example of, crazy, right? That's an example of connascence of manual task, we call it. So manual tasks happen when expanding the functionality of your code requires some tasks to be executed outside the code base. Right? That's the worst kind, because we are actually writing software exactly for the opposite reason. Right? We want to automate things so that we don't have to do manual stuff. Right? So the one that write the software with conditional manual tasks actually do the opposite for themselves. That's why we put it at the top of the ledger. So add enough manual tasks and teams will spend more time trying to make things work, fidgeting with scripts and configuration, than actually focusing on writing well-designed code. Who said so? Myself. Sometimes I like to quote myself. So, concluding, it's all about the design, says always my friend Pedro. And yes, we know the past, but cannot control it. We control the future, but cannot know it. That's a quote from Claude Shannon, the inventor of entropy for entropy in information systems, right? The thing is that in software development, it is not completely true, because we can change the past. It's called refactoring. And so if we are able to create and maintain good design, we are also able to do more refactoring and more effective refactoring all the time. And that will keep the effectiveness up even with time, and actually having the impression sometimes that it gets even faster with time. Something that doesn't happen when you have bad design and you seem to start really, really fast to just get entangled a few weeks later. In software design, we have many tools, some like coupling, cohesion, connascence, design, and code smells, gives you an understanding of the past. They are metrics to tell if your code, the code that is already written, is good enough or can be improved. For the future, we have guidance with principles, right? Object calisthenics, solid principle, 4 elements of simple design. So these things are all connected, right? All those tools at the end of the day goes to touch the same thing. So in this piece, order flow, right? We execute something, right? We generate an ID, we process an order, and then process an invoice. It has a lot of bad things, right? Long parameter list, but can be expressed as connascence of position. We have no single responsibility because it generates an ID and then process orders. So how many responsibilities does it have? A lot, right? It's low. It does have low cohesion because it touches so many things. It should do one thing only. And we have data coupling, right? We pass data clumping around, right? Primitive obsession, all integers. If we fix the connascence of position in this way, we remove the ID generation, we get an order passed, and then we process it and we send the invoice. We clean all those things at once using connascence of name and type. The idea is that connascence, coupling, cohesion are good for the same thing. And what we are actually seeing here is the overall entropy of our system. And entropy is the degree of disorder of a system. So the way to increase the order to sort out the system pass by improving the connaissance. So learn the rules like a pro, so you can break them like an artist, as Pablo Picasso said. Thank you.